Just this past December 2025, an event occurred in the energy sector worthy of the history books. This isn't a test tube reaction in a lab, nor a scientist's PPT concept, but a genuine industrial reality. On December 20th, 2025, the world's first commercial supercritical CO₂ power generation unit, Chaotan One, was officially declared ready for commercial operation. What does this mean? It means that what textbooks call the holy grail of next-gen power generation has stepped off the blueprints and into reality. Today, we are going to talk about this seemingly counterintuitive black technology. Why are we replacing water with carbon dioxide? And why did this technology make us wait 80 whole years? First, let's stretch out the timeline. Although the news happened just days ago, this idea is actually as old as the hills. Back in the 1940s, right after WWII, engineers were already wondering, besides water, is there a better medium to drive turbines? By 1967, American scientist Ernest Feher published a classic paper, formally proposing the theory of the supercritical thermodynamic cycle. In his calculations, the system's efficiency was shockingly high, and its size absurdly small, suitable even for spacecraft. But here's the problem. If the theory was perfect in 1967, why did we have to wait until 2025 to see the first commercial power plant? Where did those missing 6 years go? The answer is cruel. We could calculate it, but couldn't build it. Just like AI had neural network theories 50 years ago, but only exploded recently with powerful chip computing power. Supercritical CO₂ power generation is a beast that's hard to tame. It needs to withstand temperatures of 700 degrees, while handling immense pressure equivalent to the deep ocean. In the past, our materials science simply couldn't do it. Pipes would corrode, bearings would leak, machines would explode. This was a materials science marathon spanning half a century, until just recent years, with breakthroughs in special alloys and precision machining. Did we finally build a cage capable of locking up this beast? Okay, enough history. Here comes the core question. Why go to such great lengths to replace perfectly good water with carbon dioxide? Our existing power plants, whether coal, gas, or nuclear, are essentially just boiling water. Boiling water into steam, steam expands to drive turbines. But water has a huge flaw. Changing from liquids to gases requires absorbing massive heat. This is called latent heat. This energy is actually largely wasted during conversion. Furthermore, when water becomes steam, it expands 1,600 times in volume. So we need to build turbines as big as houses to capture this steam. But carbon dioxide has a magical state called the supercritical state. When temperature exceeds 31 C and pressure exceeds 73.8 bars, carbon dioxide breaks the laws of physics. It is neither gas nor liquid. It has the ultra-low viscosity of a gas, moving incredibly fast, while having the high density of a liquid, packing a punch. Crucially, it doesn't need to go through the process of boiling. Just give it a little heat, and its pressure soars dramatically. In other words, its heat transport efficiency is extremely high. This is the physics principle behind why it beats steam. The change this technology brings, if seen with the naked eye, is visually shocking. Imagine a traditional steam turbine generator. It might be the size of a small house, with absolutely massive blades inside. But for a supercritical CO₂ turbine of the same power, it might be only the size of your desk. That's right, the volume is reduced by a full 10 times, or even more. What does this mean? It means future power plants, one teeny giant factory buildings, drastically lowering construction costs. And regarding efficiency, traditional steam generation tops out at about 40% thermal efficiency. It's hard to go higher. but the supercritical CO₂ cycle can easily break 50%. In the energy sector, every 1% increase in efficiency is worth hundreds of millions of dollars, let alone an immediate jump of more than 10%. So where is this amazing technology used now? The unit commercialized in China these past 2 days is in a steel mill. It uses waste heat that would otherwise be lost in steel production to drive the CO₂ generation. Previously, this heat wasn't hot enough to boil water, but now it's just right for carbon dioxide. But this is just the first step. The true story C for this technology is in nuclear energy and net zero emissions. Future small modular reactors SMR, where space is at a premium, cannot fit a huge steam turbine room. The compact CO₂ turbine is its perfect match. And there's the alum cycle technology being developed in the US, which directly burns natural gas while capturing 100% of the produced CO₂ for recycling, achieving true zero carbon power generation. From the concept in the 1940s to the theory in 1967 to the official commercialization in 2025, humanity has walked a path of 80 full years just to eliminate the need to boil water. The energy industry is a giant ship. It turns slowly, but once it starts turning, its momentum is unstoppable. Perhaps in another 10 years, power plants will no longer be behemoths puffing white smoke, but precision boxes hidden in city corners and factory basements. 2025, the year one of supercritical CO₂ power. We are witnessing history. If you like this kind of hardcore tech science, don't forget to subscribe to my channel. See you in the next video.